The world's largest energy transition is being powered by the world's oldest fossil fuel. China is installing more solar panels and wind turbines than any nation in history, building a renewable empire visible from space. Yet last year, it also burned more coal than the entire rest of the planet combined. This isn't a contradiction. It's a dependency. The superpower that leads the future cannot escape the fuel of the past, because the transition itself is made of coal. Every solar panel, every wind turbine, every kilometer of high-voltage cable is forged in an industrial system that still runs on black rock. This is the energy historian, uncovering the hidden systems that power civilization. And the story of why a superpower can't quit coal begins not with policy, but with a single staggering number: 700 million tons. That's how much steel China produced last year, more than half the world's total. To make 1 ton of steel, you need about zero point 0.6 tons of metallurgical coal. The math is brutal and non-negotiable. The furnaces that build the future are fed by the past. But steel is just the visible layer. Beneath it is cement, over 2 billion tons annually. Cement kilns burn thermal coal to reach temperatures that turn limestone into clinker. Then there's the glass for solar panels, the aluminum for frames, the copper for wires, the concrete for foundations. Every single component of a green energy system is, itself, a product of immense heat and industrial process. And in China, over 60% of that industrial heat still comes directly from coal. The transition is not replacing coal, it is consuming it. Now, think about that for a moment. We imagine the energy transition as a substitution. Coal plants are retired, replaced by wind and solar farms. But that's only the electricity grid. It ignores the material foundation. Building a single wind turbine requires hundreds of tons of steel, concrete, and fiberglass. A solar farm needs thousands of tons of aluminum and glass. To manufacture these materials at the speed and scale China is attempting requires an energy input so vast, so dense, and so reliable that only one source can currently provide it. Renewables generate electrons. Coal provides the brute force thermodynamics of civilization. The green future is being built on a black foundation. This creates a paradox of scale. The more renewables you build, the more coal you need in the short term to build them. It's a self-reinforcing loop. China's renewable rollout is so massive that it's creating its own fossil fuel demand. Every gigawatt of new solar capacity requires an upfront energy investment that comes largely from coal-fired power and coal-fired industry. You are watching a system trying to bootstrap itself into a new state, using the only tool massive enough to do the job. The timeline for change is set by industrial metabolism, not political promises. Now, you might assume this is a temporary phase, that once the renewable infrastructure is built, the coal can be phased out. But here's where the system gets locked in. That new infrastructure doesn't just generate power, it enables massive economic growth, which in turn demands more materials, more buildings, more everything. The cities, highways, and factories that renewables will power also need steel and cement. The demand for coal-based industrial heat isn't a one-time cost, it's the ongoing metabolism of a growing industrial civilization. China is not just building a new energy system, it is building a new version of its entire economy. And that economy's appetite for primary materials is insatiable. This is the hidden asymmetry of the energy transition. The West outsourced its industrial base and its coal consumption decades ago. Our deindustrialization looked like decarbonization on paper. We closed our coal mines and smelters and imported our steel, solar panels, and batteries from places like China. We counted only the emissions from our own territory, China. By choosing to become the world's factory, absorbed the physical and carbon cost of global consumption. Now, as it attempts to decarbonize its own grid, it must also feed the furnace of global demand for green technology. It is trying to solve two equations at once: power its own development and manufacture the world's transition. Both answers point to coal. But that dependency is geographic, not just technological. China's coal is domestic, abundant, and cheap. Its renewable resources, while vast, are intermittent and far from its industrial heartlands. The sun shines brightest in the western deserts. The wind blows strongest in the northern steppes. But the blast furnaces are in Hebei, and the factories are in Guangdong. Moving gigawatts of electricity across thousands of kilometers requires a grid of unimaginable complexity, and cost a grid that itself requires more steel and aluminum to build. Coal, by contrast, can be mined in Shaanxi and shipped by rail directly to the factory gate. It is a point-source solution for point-source energy intensity. In the calculus of energy security for a superpower, domestic coal is a strategic asset. Imported gas or oil is a strategic vulnerability. So we arrive at the mechanism line, the compressed truth of this entire structure. The energy transition is not powered by politics, it is powered by infrastructure. And that infrastructure is made of coal. Let's ground this in a human anchor. Picture a foreman at a steel mill in Tangshan, the city that produces more steel than the entire United States. His shift starts at midnight. Behind him, a blast furnace roars at 1500 degrees Celsius, fed by a continuous stream of coking coal. The steel being poured tonight will become rebar for the foundation of a new hydroelectric dam in Yunnan. It will become the pylons for an ultra-high voltage line that will carry solar power east. He's not burning coal to keep the lights on. He is burning coal to build the machine that will eventually make coal obsolete. His work is the physical manifestation of the transition's deepest contradiction. The system requires his furnace to keep running in order to build its replacement. This isn't a Chinese story. It's a replay of a much older pattern. Look at Britain at the height of the Industrial Revolution. The transition from water wheels and charcoal to coal-powered steam was not a clean switch. It was a cascade of dependencies. To mine more coal, you needed steam engines to pump water out of deeper mine shafts. To build better steam engines, you needed more precisely machined iron. To machine that iron, you needed coal-fired forges. The new energy system was built by and depended upon the old one. The first industrial revolution was built on coal, by coal. China is in the throes of its own industrial revolution, but with a crucial difference. It is simultaneously attempting a second, green revolution on top of the first. The layers are compressed in time, creating overwhelming demand for the foundational fuel. The numbers tell the story of a system hitting physical limits. China has added over 1,000 gigawatts of coal power capacity in the last 2 decades. But in the last 2 years alone, it permitted another 200 gigawatts of new coal plants. Why would you build the infrastructure you're supposedly phasing out? The answer lies in grid stability. Wind and solar are variable. They need backup. In the West, that backup often comes from natural gas plants that can ramp up and down quickly. China has little domestic gas. Its backup is coal. These new plants are not designed to run constantly at full capacity. They are designed to idle and then spin up to full power within minutes when the wind drops or the sun sets. They are the shock absorbers for a renewable grid. They exist not to provide baseload, but to provide flexibility, a service renewables cannot. This reveals the second, subtler dependency: inertia. A traditional grid, powered by giant spinning turbines in coal and nuclear plants, has built-in physical stability. The sheer mass of those rotating generators keeps the electrical frequency steady. A grid powered by inverters from solar panels has no inherent inertia. It is digitally synchronized and far more fragile to sudden disturbances. To compensate, China is building coal plants that can provide this synthetic inertia, essentially using coal to mimic the stability that coal once provided naturally. The transition requires coal to solve the problems created by moving away from coal. The financial lock-in is just as powerful as the physical one. A coal plant is a 40-year asset. The banks that financed it, the provinces that built it, and the workers who operate it all expect a return on that investment. Retiring a plant decades early isn't just an environmental decision, it's a financial nuclear option, wiping out billions in capital and potentially triggering local debt crises. In China's state capitalist system, where provincial governments own many of these assets, the choice is between cutting off a revenue stream for millions or continuing to burn coal. The path of least resistance is to keep the plants running, even at lower capacity. The system is held hostage by its own sunk costs. So, is China lying about its climate ambitions? No, that's the wrong question. The right question is, what is a superpower actually optimizing for? The answer is not carbon reduction in isolation. It is a hierarchy of needs. First, industrial growth and social stability. Second, energy security and geopolitical independence. Third, environmental goals. When these priorities clash, the first two win, every time. Coal serves the first two masters perfectly. It is the ultimate tool for a state that needs to control its own destiny. The transition timeline is set by this hierarchy, not by climate models. This brings us to the asymmetry reveal. Who pays for this system? The cost of China's dual-track strategy building renewables while expanding coal is borne by its state-owned banking system and, ultimately, by its citizens through debt and pollution. The benefits, however, are captured globally in the form of cheaper solar panels, batteries, and electric vehicles. The West gets the green products without the black smoke. China gets the strategic depth of energy independence, but also the legacy of an industrial system that will take generations to reconfigure. It's a transfer of environmental impact across geography and time. The conclusion is unsettling. A superpower can't quit coal because coal is not just an energy source. It is the physical embodiment of concentrated power, industrial momentum, and strategic autonomy. The transition away from it is not a simple technical switch. It is a multi-generational re-engineering of civilization's material base. For China, coal is the bridge, the foundation, and the safety net all at once. The system is trying to perform open-heart surgery on itself while still running a marathon. The patient cannot be allowed to slow down. Most people assume a clean energy future means simply unplugging the old system and plugging in the new one. Drop your answer below. I'll break down why they have it backwards in the next episode. If this changed how you see the system, subscribe. The hidden infrastructure is always there. Now you know where to look.